All right, class, we're coming to the end of chapter 3, and we're going to look at a new strategy on how to solve story problems. And that strategy is this idea of using charts. I have to be honest with you, when I first started using charts, I wasn't real happy. But now that I've used them for a little bit, it is a great tool to effectively organize your material or your data so you can solve this story problem. So I'm starting out with this first problem. We're not going to solve it first. We're going to actually look at it at the end and solve it at the end because I want to work a few easier ones first. But if we look through here, if you read this story problem, it says 9 cartons of juice cost the same as 5 fruit cups. 1 fruit cup costs 50 cents more than 1 bowl of soup, while 1 bowl of soup costs 50 cents more than 1 carton of juice. What would be the cost of each item? A carton of juice, a fruit cup, and a bowl of soup. And I'm going to prove to you when we get to the end of the lesson that charts are very helpful to solve these kind of problems. But we're going to start with some easier problems first. So let's go ahead and look at your note sheet, and let's look at problem number 1. It says, Dominic bought some boxes of lemonade at 60 cents per box. He bought 5 fewer boxes of apple juice at 40 cents per box. And then my question is down here. The question says, how many boxes of each did Dominic buy if he has $10? Well, when I go through here, the chart's already drawn and labeled for you. So let's figure out, what do we know? Just by reading that problem, what information do we know already? That's right. If I look through there, they told me how much each box costs. So we can read through there, and we know that lemonade costs 60 cents a box. That's right. So we know that lemonade costs 60 cents a box, and we can read through there and we can figure out that apple juice costs 40 cents a box. So that's what we know just by reading the problem. Well, what are we trying to figure out? Well, the question says how many boxes. So that's, now we need to go back and fill in that column. Now it says Dominic bought some boxes of lemonade at 60 cents per box. So I'm going to make lemonade be X. But now he didn't only buy lemonade, he bought apple juice as well. And so what are we going to do for apple juice? Well, we've got a clue word. It says that he bought 5 fewer. So we're going to make this X minus 5. We know that clue word fewer means subtraction. So now, to figure out our total cost, we just multiply across each row. So for lemonade, he's going to pay 60 cents a box, and we're going to let the box be X. For apple juice, he's going to have to pay 40 cents a box, and so we're going to have to use some distributive property on that one to get the job done. All right, so now that I have my chart, we need to come up with our equation. Well, it says he had $10 to spend. So we're going to realize that it's going to be the lemonade, which was 60 cents a box, plus the apple juice, which was 40 cents a box, and he still had a total of $10. Now, if you notice, I didn't put the dollars and cents sign in. I'm going to keep everything as cents, and it'll make it a little bit easier for us as we go through and solve. So, what do you think we need to do first? Yep, that's right. We need to take care of our distributive property. So we've got 40x, and 40 times negative 5 is negative 200. That's right. Next thing we need to do is we need to combine like terms. So 60x and 40x is 100x minus 200 equals 1,000. Oh, who's our floater this time? 200. So we're going to use our inverse operation. We're going to have to add 200 to both sides. So now I've got 100x equals 1,200. If I divide both sides by 100 to get that x alone, x equals 12. Now we found x, but what was the question? Well, the question says how many boxes of each. So when we found x, if x equals 12, then we know that he bought 12 boxes of lemonade. Well, now how are we going to find apple juice? Yeah, we got to go back up to our chart. And so we know apple juice was x minus 5, so that means 12 minus 5, so he bought 7 boxes of apple juice. Now remember, when you're doing a story problem, you got to show me a check somewhere. And so we've solved the first problem using a chart. Now let's go on to the next story problem. This is number 2 at the bottom of your note page. It says, solve the problem using the 2 given facts. Complete the chart to help you solve the problems. It says, find how much Eric earned if his earnings were $27 more than the combined earnings of Kaveh and Max. Well, here's what we know. It says Kaveh worked 3 hours more than Max and 7 hours less than Eric. And then we know that Max earns $7.50 an hour, Kaveh earns $6 an hour, and Eric, well, he gets a whopping $9 an hour. So if I look up there, what do I know already? Which column of that chart can I fill in? Well, they already told us all of the hourly wages, so let's go ahead and fill those in. Well, we know that Kaveh makes $6 an hour, and we saw that Max makes $7.50 an hour, and then remember, Eric, he gets the whopping $9 an hour. So we know how much money each makes an hour. We know their hourly wage. Now we've got to figure out how many hours they worked. So if we look back up here at bullet number 1, that's going to help us come up with our, what we would say, let statements to figure out everybody's hourly hours worked. So when I look there, who does everybody's hours depend on? Kaveh worked 3 hours more than Max and 7 hours less than Eric. Yeah, that's right. Everybody's hours depends on Max. So let's go ahead and make Max be X. So Kaveh works 3 hours more than Max, so that's going to be X plus 3. And now Eric. Well, Eric's 7 hours less. Remember that inverse operation thing. So we've got 7 hours for Eric and 3 hours for Kaveh. So this is going to be X plus 10. So now I'm going to go to the next slide because it's already got the chart filled in for us. And so here it is. We've got Kaveh and Max and Eric. Now remember, to find the totals at the end, I use my distributive property. So for Kaveh, it's going to be X plus 3 times $6 an hour. So that's how we got 6X plus 18. For Max, it's just X times his wage, which is $7.50. And then for Eric, it's X plus 10 times his whopping $9 an hour. And so that's how we got 9X plus 90. Now, we need to go back and read that beginning statement to help us with our equation. It says, find how much Eric earned if his earnings, okay, Eric's earnings where's our equal sign, 27 more, so that's where the 27 plus, and then the combined earnings of Kaveh and Max. And so that's in my parentheses. So does everybody kind of understand how we came up with that equation? All right, so now we've got to solve. All right, so what do you think we should do first? Yes, we've got to go over here. Let's go ahead and 9X plus 90. And if I look on the back half of the equal sign, I've got some like terms I can put together. We can put my x's together. So 7.5 plus 6 is 13.5x. Remember, when you're adding decimals, you have to line up the decimal places. And then if we put my 27 and 18 together, we get 45. Oh, well, now we're back to problems where we've got x on both sides. So if I have x on both sides of my equation, I have to get letters on one side and numbers on the other. So I'm going to go ahead. I'm going to move this 9x over. I'm going to subtract 9x from both sides. So I've got 90 equals 13.5x minus 9x is 4.5x plus 45. Yeah, our floater this time is 45, so let's subtract 45 from both sides. And when I do that, well, 90 minus 45 is 45 equals 4.5x. We've got to divide both sides by 4.5 to get x alone, so we're going to get x equals $10. Now we found X, but what was the question? Well, the question was, what was Eric's earnings? All right, so we found X. We've got to go back and put that into Eric's earnings. We're back up here, which was 9X plus 90. Well, we now know that X is 10 plus 90. And so what was Eric's earnings? He made $180. Okay, everybody kind of understand where we went there? And again, make sure you show me a check. Let's look at our next problem. Problem number 3. Oh my goodness, I just gave you a blank chart and we've got to fill in the chart as well. Well, let's see what the story problem says. It says, a stalk of celery contains 7 calories and a carrot contains 20 calories. A total of 45 carrots and celery sticks contains a total of 575 calories. How many carrots are there? Well, what are we talking about? Well, we're talking about carrots and celery. All right, so let's go ahead and fill those in. We've got carrots and we've got celery. Well, now that we figured out we're talking about carrots and celery, what 2 things do we know about carrots and celery? Well, we're talking about calories. So we're talking about the calories in carrots and celery. And the other thing we're talking about is the number of veggies. Now I'm going to say veggie sticks. I'm just going to write numbers of veggies. Okay? And this last column is always total. Okay, so let's go up here and let's read the first sentence again. It says, a stalk of celery contains 7 more calories than a carrot, and a carrot contains 20 calories. So that's actually what we know, okay? We know that a carrot has 20 calories, and we know that a celery has 7, okay? And what are we trying to find? Well, we want to figure out how many carrots there are. Now, here's a little trick to the trade. Since all I need to solve for is carrots, let's go ahead and make carrots X. If I make carrots X, when I finally solve for X, I'm done. I've answered the question. Now, if carrots is X, what is celery going to be? Well, remember it said I had a total of 45 carrot and celery sticks. So if carrots is X, how am I going to figure out how many of them are celery? Well, I subtract carrots from 45. So this is going to be 45 minus X. Does that make sense? If carrots is what I'm looking for to figure out how many celery's left, I just subtract it from the total. So now, once again, we're going to multiply across to get our total. So 20 calories for every carrot, 7 calories for every piece of celery. And so now there's always some other number in our story problem that we need. And that's right, it says the total of all those is 575 calories. So let's see what our equation would look like. It would be the carrots plus the celery equals a total calorie count of 575. Can you finish solving that equation for me? Well, we've got 20x. We've got to take care of our distributive property. Let's see, 7 times 45, 315. And then 7 times x is 7x equals 575. We've got to combine some like terms, so 20x and negative 7x, 13x plus 315 equals 275. Who's my floater? Yeah, we've got to get rid of that 315. So in order to do that, I'm going to have to subtract 315. What I do to one side, I do to the other. Now, did you realize when I go to subtract that 315 is bigger than 275? So you may want to write it on top so it's easier to subtract. So we've got 13x equals, that's supposed to be 575. Okay, and if I subtract from over there, we're going to get 260. If I divide both sides by 13, that's right, x equals 20. So we found x equals 20, but what was the question? Well, the question was how many carrots were there? Okay, and since we made carrots x, that's our answer. The answer there are 20 carrots. Good job. Make sure you show me a check somewhere. All right, now, let's go back to the beginning. Let's go back to that very first problem. Now, when I look at this very first problem, here's what we know. 9 cartons of juice cost the same as 5 fruit cups. Okay, that's an important sentence. Mrs. Burton even underlined that in red. Do you remember a real important word from chapter 2 that helps us when we're writing equations? That's right, that word same. What does same mean? Yeah, we're going to have to know that in just a minute when we go to write our equation. So let's look. 1 fruit cup costs 50 cents more than 1 bowl of soup, while 1 bowl of soup costs 50 cents more than 1 carton of juice. Everybody's price depends on who? Yeah, who was the one that was mentioned twice? Bowl of soup, bowl of soup. So we're going to let C be the bowl of soup. Now I've got to go back and figure this out. Now it says 1 bowl of soup costs 50 cents more than 1 carton of juice. So that means I'm going to make carton of juice 1 fruit cup costs 50 cents more than 1 bowl of soup. So that means fruit cup is going to be C plus 50. And then juice is going to be C minus 50. So you may want to go through and read it again. 1 fruit cup costs 50 cents more than a bowl of soup. So that's where this came from, 50 cents more. But 1 bowl of soup costs 50 cents more than the carton of juice. So that's where we're going to get that from. Now, here's where that first sentence comes in. We know that 9 cartons of juice cost the same as 5 fruit cups. So, once again, we're going to multiply across to get our total cost. So, 9 times the juice is C minus 50. Okay? 5 times the fruit cup, C plus 50. All right. Now, what is our equation going to look like? Because it says the word same up there, here's what we've got. 9 juice boxes, C minus 50, is the same as or equals 5 fruit cups. Okay, what do you think we should do first? That's right, distributive property. So 9C minus 450, distributive property times 2, 5C plus 250. All right, I am going to subtract 5C from both sides, get my C's on one side. And now, who's our floater? That's right, we got to add 450 to both sides. So now I've got 4C equals 700. And we're going to divide both sides by 4. Okay, so if I do that, 4 goes into 700. Well, that's once. 3, that's going to be 7, 28. There we go, 175. So C equals 175. So what did we just figure out? Well, we just figured out the cost of a bowl of soup. So bowl of soup is $1.75. Well, how are we going to find juice? Well, remember, juice is C minus 50. So we're going to subtract 50 cents from my soup bowl, and we're going to get 125. And then to find the fruit cup, remember, if we go back to our chart, we're going to add 50 cents. So that should be 225.